And welcome to the Daily Space Weather. This is Smasho coming at you from the Smash News Network. Least busted name in news. We've got some riveting activity. I woke up this morning to an M-class solar flare. What was your morning like? Let us know in the comments. And let's get back to it, as we've got stunning imagery here from all around the different wavelengths from SDO. And you'll see right at the end of this video, you'll see an M-class flare, some plasma reorganization happening, some CMEs happening. Most of the solar activity is currently in the northern hemisphere. Things are about to get pretty quiet in the south, as we've got a major sunspot group setting in the southwest, and many umbrae setting in the northwest. So we'll have a huge dip in sunspot number today after those major sunspot groups set. The likelihood of very large solar flares, including M and X-class flares, remains for another solid 24 hours. So here is the SDO continuum imagery, the intensity gram rather. So we'll have a big dip in sunspot number here as these two groups set. There's also a huge bridge of plasma in between them, extending well out into the corona. Not visible on most of the imagery because those large plasma filaments exceed the angle of view of things like the SVO and even the GOES 16 SUVI. So here's the colorized magnetogram, and things have been mostly stable here. Let's go back to the intensity gram for a quick moment. A little bit of sunspot reformation happening up there, but fairly stable for the most part. And let's take a brief look at what's happening on Crescent Earth. Check out the surreal imagery from Stromboli's Sierra del Fuoco. Great time-lapse imagery there, showing some lava cascading down toward the sea. There's a long description on Volcano Discovery about what's been going on in Stromboli. There was a landslide and standard issue effusive eruptions happening there. If you want to read about that, volcanodiscovery.com. Click the Volcanoes Today page, and you can read all about that. Suwanosejima also erupting, producing a 6,000-foot ash plume. Semeru exploding, flight level 140. That's a 14,000-foot ash plume over East Java, Indonesia. Kilauea still erupting. The Halema Uma'u lava lake still has some hot spots. Sulfur dioxide emissions reached 3,000 tons on January 20th. Popocatépetl exploding in central Mexico, flight level 210. It's a 21,000-foot ash plume. Not sure if Fuego in Guatemala or Sabancaya in Peru are erupting, but please don't pole vault the caldera. And let's see what's been going on with earthquakes. There was a 5.4 at Malibu Beach. There's the 90-day bar graph of what's going on in terms of seismic activity. So here's the largest quake of the past 24. It was a 6.4 in Argentina, deep into the South American continent, well to the east of the Andes Mountains there. And it's at extreme depth also. So that one came in at 1837 Universal Time yesterday evening. Depth estimated over 600 kilometers there. That 6.4 magnitude quake. If that happened at the surface, that would be like an 8 magnitude quake. And let's check out the rest of the list here. Indonesia had a 5.2. There's the location of that Indonesian quake. And that was a 6.4 at Argentina. Indonesia also had a 5.5. Malta had a 5.3. So that's that. Keep in mind, folks, any earthquake can be a foreshock. Don't forget. Any earthquake could be a foreshock. Japan also had a 5.2. There's a location of that. There you go. There's a 4.2 in California at Malibu Beach, 16 kilometers south of Malibu Beach. Let's briefly take a look at that. That's a rather significant quake there. Likely felt in LA. Anaheim, Long Beach, Huntington Beach, Ventura, etc. Also Santa Clarita. There's a location of that 4.2. That one came in at 10 o'clock Universal Time this morning. So also some aftershocks happening there, like this 3.5 and this 2.8 and this 2.6. And let's get back to space. So yeah, spectacular activity here kicking off in the western limb. And you can see some of the extended corona here. You see these loopy features that extend well out of the field of view there. Those are going to be way out like this. And yeah, expect more major flares. Large flares are more likely at the limb. We've got some flares associated with plasma splashing back down. You'll see up here some plasma reorganization happening there and some brightening of the chromosphere. Just fantastic imagery there from SDO. That's 304 plus 193 angstroms, ionized helium plus ionized iron. The 10.7 centimeter radio flux dropped down to 180 solar flux units, and we can expect it to fall even farther here as those major sunspot groups are setting. No major sunspot groups are rising or forming to replace them, so we can expect to see a precipitous drop in this. The black line here is the radio flux. The red line is the sunspot number, and if you're a regular viewer, you are aware of how proportional those two features of solar activity are. Here's your space weather enthusiast dashboard, and interestingly, no geomagnetic storm or unrest in the forecast here. So surprisingly weak showing so far from the coronal hole high-speed stream. We barely even saw a density wave, and it seems like it's showing up late to me. Let us know in the comments what you think about that. We'll get to the solar wind parameters here in a moment, but NOAA not forecasting any geomagnetic unrest or storm conditions. Planetary K index is currently at 0.33. A very geomagnetically calm situation. And here is Earth's magnetic moment from space for the past 4 hours, as modeled by the Space Weather Modeling Framework. So some significant variations in the solar wind happening here. Again, we'll show you the real-time solar wind data in a moment. That's 4 hours of Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. Should also be 4 hours. And this will show you the most likely places to see aurorae, pipeline, railway, and power line induction. Its geospace delta B changes to Earth's B field. The field that goes through the magnet, this magnet being the Earth. You can see some intensifications there, especially in the southern hemisphere. It is summer down there, after all. And here's the real-time solar wind. So the real-time solar wind here showing some variations. That looks like a CME impact, frankly. I mean, we saw a big shift in the BZ here. That's the red line on the top. That's a vertical component of the magnetic field as measured at Lagrangian point 1. And, oh, I see what happened. We've got a changeover with the instrument here. We've got the ACE to Discover switchover. So that's causing variations there as those spacecraft are picking up quite different parameters. Current conditions are measured by the Discover. Solar wind speed 508 kilometers per second. Solar wind density 11.02 protons per cubic centimeter. Expect to see a spike in that solar wind density at any moment because, again, expecting to see a coronal hole high-speed stream impact. Next, some magnetic data. There are the GOES 16 and GOES 18 magnetometers. A little divergence happening most recently here. Keep in mind it is midnight local time for the satellites, or close to it. That gives you some indication where they're located. That's the N's and M's. That's noon and midnight local time for the GOES 16 and GOES 18. Today's featured product, by the way, is Because Reasons. If you haven't checked out the merch, we decided to start producing merch because reasons. So give Smash staff a raise by picking some up. Of course, you may ask yourself why so many bad decisions have been made over the past pushing 3 years now. Come March of 2023, we'll be 3 years into terrible decisions made to the point where they've destroyed the entire economy of the planet and undermined all human institutions. Yeah, all human institutions, including everything from the family to universities to science to the medical industry and so on and so forth. Suddenly, within the past couple of years, nobody's able to do their own job. Isn't that incredible? How are certain middle management figures undermining your life right now? Oh, man. As certain mandates continue to exist, we encourage people to migrate to the U.S. for additional freedom. It's still better than most places out there. And why have such bad decisions been made? Because reasons. So check out the links below the video is my point. If you click the red bubble link, you'll find our shop in order of best selling. Our best seller is Do Not Pole Vault the Caldera. And yes, if you're going on a volcanic vacation, leave your vault pole at home. Check out the merch. Some of it's designed to create conversations, impart wisdom, or perhaps just create an inflammatory reaction. How about the fear-mongering that is currently existing on YouTube? It's pretty pathetic. And congratulations on surviving a global pandemic so far. If you want to support the channel via subscription services, we are still on Patreon. We've got 3 membership levels over there. So feel free to support the channel that way. And of course, the best way is through the Smash Team site at smashomash.com/Smash Team. That's the official subscription services site. We launched it back in October of 2021. And the best value is the gold annual paid-up subscription. It includes complimentary merch. It's like getting 4 months of the gold level membership for free. So if you are a Smash Team member, make sure you log in and click posts. You'll see our latest. We do send out email alerts for our daily space weather and meteorology segment videos, also for disasters. And we put up information there that nobody else gets to see. So that's where the most exclusive content is located. We've even informed the gold Smash Team level of the mechanism underlying the solar sunspot and solar polar field reversal cycles. So thanks to gold Smash Team members, you're helping us write one of the most important papers in hundreds of years at smashomash.com/Smash Team. Next, let's look at the polarity of the solar plasma. So at the moment, Earth is just snapping into a South Pole current sheet. Expected it to be here a little bit earlier, but it's probably here now. South Pole current sheet depicted in red, North Pole in green. And we'll also take a look at the line of sight field plot. Here the sun's B field is depicted in blue, north field in green, south field in red. And let's go to coronal holes next. We've got some South Pole oriented ones rotating in, and we can see some migration here of the south solar polar field. You can see it finally making its way up here to the north. Great imagery there as the south solar polar field has finally left the South Pole, at least from this perspective. So finally, and it looks like the North Pole field is also starting to head down toward the south. So that is what you would expect to see in a solar cycle. The field reversal process has been taking its good old time. And let's take a look at the view from SDO, as we've got some South Pole oriented coronal holes here. So these are South Pole, these are North Pole. And the current sheet boundary is something like this right now. As we watch the cycle continue, it's time to move to sunspots. So we'll see a huge reduction in sunspot number in the next 24 hours, as we've got the setting of sunspot 3192 and 3190. Besides that, things have been mostly stable here. There may be one new named group up here in the north, as a group has evaporated and then sort of reformed. Whether that'll get named a new sunspot or not sure on that one, but we'll see a drop in the sunspot number today. Let's take a look at the SDO imagery. There's your SDO magnetogram for the past 24. Let's zoom in a little closer here. and we have got some spectacular imagery of that western equatorial region. First, the SDO intensitygram. So yeah, mostly stable here for the past 24 hours, and we'll be down to 0 sunspots in the southern hemisphere by the end of the day today, unless some new groups form or rise. Still lots of sunspots in the northern hemisphere, but a big dip in sunspot number, and radio flux likely coming. Next, we'll go to solar flares and energetic particles. Sometimes solar protons take as little as 20 minutes to reach Earth, especially when they're associated with strong flares. At the moment, we don't see anything of the sort. The ghost proton flux is indeed flatlined. So I woke up this morning to this M-class flare. That was literally the moment right about there is where I woke up. And yeah, so that's the largest flare of the past 24 hours. And if you've got comments to leave directly for the sun, please leave them in our comments. We've been told by other viewers that the sun indeed watches our videos. So if you're able to communicate with El Sol, drop us a line. We'd be more than happy to provide an interview, especially if there's some way to translate all the information coming out of that object. So here is, and thanks for leaving a comment, Jackie2, who woke up at the same time. Good day to you indeed. Located in Finland. Fantastic. Are you the person who taught me how to pronounce Oulu? So here's the last 24 hours in 94 angstroms. One of the better wavelengths to view solar flares. We'll zoom in on that western equatorial region. To show you the best imagery that you'll find anywhere in the world of the sun, and the most comprehensive space weather as well. So here is the 131 angstroms wavelength as well. We've got additional imagery here, and keep an eye on this area as the likelihood of additional solar flares, including X-class flares, is indeed greater than not. In other words, it's, I'll say, 70% likely to see X-class flares here. We've still got another 24 to 36 hours before that becomes less likely. You don't need to be able to see the sunspot for it to be able to produce a large flare. That's my point. So there's 94 plus 131 angstroms. We'll also subtract the 94 angstroms and add 171 angstroms. And here's the full disk view in those wavelengths. So, of course, we're always interested in what's going on overhead, and so we encourage you to know about it as well. We like to show a star chart daily on the channel to help orient our viewers as we zoom out to our solar system forecast and coronal mass ejection forecasts and so on. So that's our next move. Here is the sky overhead at Lehigh Valley, Pennsylvania. That's from skyandtelescope.org, by the way. And once again, if you're up before dawn, you may see Mercury rising ahead of the sun. If you've got a low horizon and low light pollution and clear skies, Mercury there. And just press now to get the latest data on your star chart from this website. I like the way it shows the view here. That's super useful. And let's do a solar system forecast. So here's what's going on in the solar system. We'll do the 1 week forecast. We've got a crescent waxing moon here at the moment. And in 7 days, we'll have a gibbous waxing moon, as Earth is on a very lonely side of the sun here, a side devoid of gas giants. Next, coronagraphs. Here are yesterday's coronagraphs. We did indeed have some coronal mass ejections. You're probably wondering if they're earthly directed. And thanks for leaving a comment, one audio, about Jupiter. Congratulations on citing Jupiter last night. Let's look at today's frames as well. Again, you're probably wondering if those coronal mass ejections are earthly directed. We'll get to it next. There are today's frames from George Mason University. And let's take a look at stereo A to help get some trajectories on those coronal mass ejections. We'll also look at Soho Lasco C3. Now, for you new viewers out there, Earth would be off in this direction. From stereo A's perspective, again, it is located at Lagrangian point 5 here, trailing the Earth orbitally speaking, and seeing space weather ahead of Earth, hence the term stereo A. Stereo ahead. And basically, none of those coronal mass ejections are earthly directed. So we don't see any on the Earth line there. No surprises. Let's take a look at some 24-hour coronagraph videos. Let's zoom out to show further propagation of that solar plasma. And remember, folks, plasma in space is not exotic. Matter only needs to be about 20% ionized to be considered plasma out in space. It is a very diffuse environment, and there's a lot of ionizing radiation for everything that is not encased in some sort of shielded area, like a magnetic shield like Earth's, for example. And so neutral particles tend to be kind of rare. Again, there's a lot of radiation in space, so there are a lot of ionized particles. So calling matter plasma in space is not really any exotic anything. That's a bunch of diffuse hydrogen gas primarily blasting out of the sun, and it's not headed in your direction. Let's take a look at filaments next. As we've been doing, name that filament on the Twitter page. And we've got the rising of the James Comer filament here. So that's been hanging out for a while. Now it's finally in view. It's turned from a prominence into a filament, and it is quite huge. Julie did a good job naming that one, as it has been there for a long time. Now there are some other filaments we could name, like this prominence up here might be a good one. So anyway, if you've got a filament that you'd like to name, just hit us up on Twitter. Now, you have to name it on Twitter. You can't name the filaments in the YouTube comments or anything like that. You've got to actually name that filament on Twitter. So if you leave a comment here, we'll repost your tweet, and we'll create a graphic there pointing to the filament that you named. So make sure you tell us which one you want it named and who you want it named after. We name filaments after living people. So follow us on Twitter for that if you don't follow us for the other features, as we talk about stuff there besides space weather. Look at the pathetic censorship. We've got 372 followers. Having started the Twitter feed back in March of 2019, having 18.6 thousand tweets, and being shadow banned the entire time. What a crime syndicate. How pathetic. Twitter. It's not fixed by any stretch of the imagination, as boring, stale ideas are still propagated. Famous people and their parroted nonsense is still promoted, while the most comprehensive space weather videos in the world are barely able to be found. So here's the last 24 hours in 304 plus 211 angstroms. We included this because it does show the extended corona, so you can see once again all of these magnetic loops. They're kind of coming out like this because this is a huge structure supported by the magnetic fields, which are interacting with each other there across the solar equator. And so there's a lot more plasma besides what you can see in this imagery, is my point. So don't be surprised to see a massive CME and additional huge coronal mass ejections. So let's take a look at the past couple hours here from GOES 16 SUVI with its awesome wide field of view. Now for ionized helium, this does look like it includes most of that outer corona region there. You can see it's kind of fading out a little bit there, so keep in mind different wavelengths may have completely different profiles there. And yeah, we haven't seen the end of the flaring from these sunspot groups yet, in my opinion. I'd say there's a very, very high chance, nearly 100% chance of an X-class flare being produced by that monstrous couple of sunspots and their location as their magnetic fields interact with each other, straddling the solar equator. It's exciting stuff. It's time for bonus feature segments. Starting out with satellite charging hazards. It's smooth sailing for satellites. And let's take a look at the electron flux next. We expected this to be a little bit lower today, but the coronal hole high-speed stream has not arrived on schedule. So electron flux here much higher than expected. And NOAA almost got it right. Very close there. A much better forecast than we had, although they are expecting a dip here. So looks like NOAA perhaps is expecting a coronal hole high-speed stream to arrive after all. There is the one-year chart to put the relativistic electrons in context. They are measured by the GOES 16 and GOES 18 satellites at the F layer of the atmosphere, which is at about 300 kilometers of altitude. And there's a lot of shaking going on up there. This is the vibrational frequency of that portion of the atmosphere. Yes, the ionosphere. So there you go. And we're seeing additional anomalies in this. So we've recently seen the South Atlantic anomaly migrate from up here on the South American continent all the way to this area down here. And now, well, it looks like it may have moved even more here. It looks like it might have moved farther to the north. So now you would expect these anomalies to be closer to the equator because of the basic way that a spherical magnet's going to work. So let me get off screen. I think the South Atlantic anomaly has moved again. So it's now in the South Pacific, is my point. Let's just bring up the latest image here and look at the anomalogram. So it could be moving again here. It looks like it's closer to the equator. I mean, that's the new spot for the South Pacific anomaly, you may want to call it. Yeah. So that's certainly interesting as it's moved again here. And we could be witnessing the end of the geomagnetic excursion, folks. So, that is what you would expect to happen. You would expect, if the geomagnetic excursion suddenly ends, and ends certain YouTubers' careers as a result, you would expect the magnetic poles to start to migrate back toward the geographic poles where they are, historically typically located. So that's interesting to say the least. And, a lot of people would be very upset if the geomagnetic excursion ended because their model of grifting to make money and frighten people will dry up. So anyway, again, it looks like the South Atlantic anomaly has moved again. It's now just south of the equator in the South Pacific. It's still in the south, but barely. It's almost in the equatorial Pacific now. Anyway, there's the latest image. That's 11:30 Universal Time. Ionogram at 11:45 Universal Time. Anomalygram. That's anomaly in megahertz from a 30-day median. We'll also take a look at the total electron content, which has been highly anomalous for a solid month here. We've had very low levels of electron flux, which tend to be associated with very large GPS errors. Total electron content depicts the free electrons between your GPS satellite and your handset. So these bands down here of low electron content, those are very odd. And also these very large blobs of red are also odd. Also, these low electron contents over the Caribbean and southern South America are odd. It's just been very anomalous here in the past solid month. With the total electron content forecast, expecting huge GPS errors over most of the human population area. Free electrons up to about 12,500 miles of altitude. So let's close out the space weather section here. This includes the latest intensitygram and latest SDO magnetogram. We allow you to see it refresh, so you know you're looking at the freshest imagery. And let's say goodbye to these sunspots. They are certainly legit. That group there, I believe that had the most umbrae of any sunspot group of solar cycle 25. And this group down here had the largest umbra, I believe, the largest single umbra of solar cycle 25. So two historic sunspot groups there paralleling each other at about the same solar longitude and exchanging plasma the whole time across the solar equator. Here's the full disk rock back. We may have a new sunspot forming down here. No umbrae visible yet, so that's the current state of affairs. And before we do the meteorology segment, a quick moment to handle station identification. So It is the Smash News Network, least busted name in news. You know, we started making these videos back in, 2017 it must have been. And, we noticed that there was a niche for this content as nobody was covering the information that we wanted covered. So that's why we decided to step up and produce the content that we produce, because there was a hole in the realm of space weather. No legit daily space weather channels that I am aware of, so we decided to fill that niche. Now, I realized in the mid-1990s that I needed to take a deep dive into heliophysics because of the implications on cosmology. So if you want to support our efforts, again, please click our links. You'll find them below the video. You'll find us all over social media. Smashomash.com is the official homepage of the Smash News Network, least busted name in news. And welcome to the Neo Renaissance, as we compose perhaps the most important science paper in hundreds of years explaining the mechanism underlying the solar sunspot cycles. If you enjoy the content, press like and subscribe. If you're viewing on BitChute, make sure you go view on YouTube. You're missing most of the videos. Our playlists contain all kinds of content that is not space weather oriented, so check those out. Also, check out the 12 Days of Smashmas. Yeah, we've got a music label also. Lots of new stuff coming out from the channel. Thanks for tolerating the pathetic censorship on YouTube. And let's move to meteorology. So we're just looking at the coldest place in the world right now, which is in Siberia. How about negative 60 degrees Fahrenheit? That seems like it's a little bit on the chilly side. What do you have to say? Nearly 60 degrees below zero Fahrenheit there. Much colder than Antarctica. That is the surface temperature for the planet. And it is not exactly globally warm in Siberia. Of course, it's a little warmer in Australia, as it is indeed summer down there. And let's take a look at the wind patterns, since that is some real-time meteorology. Strong low-pressure system here, south of Kamchatka. Those are the surface winds of the eastern world. Here are the jet streams of the eastern world. Jet streams of the western world, shown here. Cold air being injected into the central southern U.S. Surface winds of this side of the planet looking like this. Surface winds of the central planet looking like this. And jet streams looking like this. Continuing on, I'm interested in what's going on in terms of clouds and fog over the Americas. Here it is. It's a 3.9 nanometer radiation satellite. More real-time data for you. And shout out to our viewers from all around the planet. Who knew we'd make so many friends and foes by putting out so many facts about space weather and meteorology? Congratulations on realizing the channel exists. Next, our weather.gov map. If your location's lit, click your location. We've got some severe weather warnings there around the Gulf Coast, including some severe thunderstorm warnings and I believe a tornado warning there. So a tornado must have showed up to have a warning. If your location's lit, click your county. We scrolled down to show you the key. That's about all we can do. We don't want the video to be too long. And we've got snow coming to Pennsylvania. So here's your GFS pressure and precipitation forecast for the next 72 hours. And a bunch of snow there coming. Also some rain expected in the southeastern U.S. So let's take a look at total accumulated precipitation based on the same GFS 72-hour model. There's your total accumulated precipitation in inches. We'll also show the total accumulated snow depth change. I'm expecting like 2 inches of snow here in Lehigh Valley, PA, which is, by the way, right about there where the Delaware River juts into Pennsylvania. Just a little bit to the west of that is where we are located here. That's the Lehigh Valley. It flows into the Delaware at the town of Easton. Anyway, that's your positive accumulated snow depth change forecast. It is based on the GFS model, so let's take a look at the Euro model as well on our trusty windy.com. So there is the next 12 hours, expecting some heavy snows there in southern Missouri and northern Arkansas. Here is the next 24 hours based on the Euro model. And there is the 72-hour forecast as things really open up there with some additional snow. Here's the difference between the Euro and the GFS model. That's the GFS. Once again, that's the Euro. Again, GFS, Euro, and let's move on to our lightning mapper. So we had some severe lightning here around the Gulf Coast, from Nolens throughout Mississippi, Alabama, and Georgia. Let's see if we've got any real-time strikes. We did certainly have some active cells here while we did show prep. So some lightning there in between Tallahassee and Pensacola. So there are the locations of those active cells. Next time you hear thunder, check out lightningmaps.org. Just west of Apalachicola National Forest. That's our full view lightning map. Keep in mind, lightningmaps.org does not have sensors everywhere in the world, but those are the active cells that are detected by blitzoltung.org. And here's some more real-time data for you. The U.S. Doppler radar map. You've got quite a bit of weather there around, especially around the southern Great Lakes. Some heavy precipitation there in southern Alaska as well. Some showers around Hawaii. We'll focus on the lower 48 to close this thing out. That is your U.S. Doppler radar. Here is your shortwave radiation showing clouds and fog over Crescent Earth. People keep trying to claim it's a sphere. Look at all the low clouds over the Atlantic and the Gulf. Major low clouds there. And here's the water vapor map. So what's going on here is you've got this pulse of dry mass of air moving up to the northeast, helping to move that. It's also creating a huge pressure gradient. So that is your precipitation line there, as that dry mass of air pushes the moisture, well, it pushes it toward me, in fact. And it looks like clear skies over most of southern Texas at the moment. Northern Texas, not so much. Anyway, there is your latest imagery, the U.S. Doppler radar map. Lots of moisture there. There is shortwave radiation showing clouds and fog. And there is the water vapor. It shows all the water vapor, not just clouds and fog, but even water vapor that's not condensed onto clouds. And that is where we will have to close things out today. Thanks for tuning in. Once again, congratulations on realizing the channel exists, and may that solar wind be at your back. Facts stated in this video are suppressed for your convenience by big tech criminal organizations. Opinions expressed in this video are not necessarily the opinions of Smash News Network, least busted name in Nev.